bit of it with you right now. Essentially, you're going to be applying the net torque equals I alpha equation, okay, to these problems. So these are more mathy problems. And one thing you need to know, and if you watch my video, you already know this, is the rotational inertia of a disk is 1/2 mr squared. And so you'll need that in 1, 2, and 3, and even 4, and even in 5. So we didn't write it there, but you need to know, just know that the rotational inertia, it's like of a record player. So we can assume that the turntable part of the record player has a mass of 0.3 kilograms and a radius of 0.16 meters. So for this one, for 5, you can use 1/2 mr squared to find the rotational inertia of the record player. So I thought I'd take a quick look at, like, say, number 1 with you, okay? So we got a 200-gram, 20-centimeter disc, 20-centimeter diameter plastic disc is spun on an axle through its center by an electric motor. What torque must the motor apply to take the disc from 0 RPMs or to 1,800 RPMs, and that is the equivalent of 188.5 radians per second in 4 seconds. Okay, so let me just kind of bust out. Let me see if I can zoom in on this a little bit so we have a little bit more to work with. Okay, and then let me see what I can kind of do here on the spot to help you. So first of all, like I said, we want to figure out the torque. So we're going to go with net torque equals, okay, just give me a second here. So we're going to go with net torque equals I alpha. That's what we're going to do. And what we see is that this is our question mark. We want to find that. So we need to, that means we must be able to calculate a value for I and a value for alpha. So we need to come up with those two things. So I'm going to start over here by finding a value for rotational inertia. And we've got I of the disk is equal to 1/2 mr squared, okay? And so that's going to be 1/2 times the mass, which is 200 grams. So we got to put that in kilograms. So that's one thing you got to be careful of. 200 grams, we got to move the decimal over 3 places, so 0.2 kilograms. And another thing is it's 20-centimeter diameter. So we need the radius, which is 10 centimeters, and we need it in meters, which means move the decimal over 2 places. So it's going to be 0.1 meters squared. Okay, so that's how we would find the rotational inertia. Are there any questions on how we'd find the rotational inertia on the kind of things I just said? Okay, so then we got to find the alpha. All right, so we got to find the rotational acceleration. And we're going to do that by using a kinematics equation. And we know the initial theta, and we know, oh no, we know the initial omega, we know the final omega, we know the time. So then we're going to want to use, and I just am familiar with the equation, so I know it's going to be omega final equals omega initial plus, or usually we write it like this, equals alpha t plus omega initial. There, okay. So final rotational velocity equals the angular acceleration times time plus the initial angular velocity. And so the numbers we'd plug in are the final, which is 188.5, and radians per second is already the right units. Alpha is what we're looking for, so that's our question mark. Time is 4 seconds, and we start from 0 rotational velocity, so 0. Okay, so that is how you'd go about solving this problem, and you're going to follow kind of a similar process on this whole assignment, where you're doing net torque equals I alpha. You have to work to find your I, your rotational inertia. And then you're probably going to have to interweave some kinematics in there as well for your alpha. Okay. So before I finish talking about this, does anybody want to ask me any questions on this? So I guess to finish the problem, we'd then calculate our I, plug it in over here, calculate our alpha, plug it in over here, and that would give us our net torque. And our net torque is what we're asked for, the torque that the motor applies. Sorry, any questions now? Okay, well then that means we have perfect timing. So we have 10 minutes right now. So your homework is to do these problems. I will, you know what I'll do is I'll just take this little video clip that I just did talking through this, and I'll make that available to you. So if you want to watch me talk through this again, you can. And so I guess you don't have to do number one, right? So don't worry about doing number one, but please do the other problems on this assignment, numbers 2, 3, 4, and 5. Okay. Let's go over to